Yesterday, if you can recollect, yesterday we had a discussion on the Doppler effect, and we took the source, approaching source and observer, both are moving. Then we got the apparent frequency. What will happen to the wavelength? Because we have to focus on the wavelength also, no? The parameter of wavelength. So what will happen to the wavelength? Wavelength in each case. Yesterday we had a only discussion on the apparent frequency only. Now what happens to the wavelength of the waves received by the person? So the formula is very simple. Okay, there's a, let me pick up. From yesterday where we have discussed, no, there in the end. Okay, from there I'll continue. Now, can you remember this? Okay, now we'll continue from here. Now, how to calculate the apparent wavelength? Apparent wavelength is given by lambda 1, or say lambda f1, I wrote it, no? So lambda 1, I'll write it. Lambda 1 is equal to V relative by apparent frequency. Try to look at this one. The waves emitted by this, they will propagate. With what speed the waves will be propagating? With a speed V. The waves will be propagating with a, let me take some other color. This is very important. Once again, putting what is the speed with which the waves are propagating? We know. With what speed the waves will strike the observer? With a speed V plus V naught. What is relative? The speed with which waves approach the observer. The speed with which the waves approach the observer. What is F1? F1 is what we have calculated. Here V minus Vs. So this will become V minus Vs by F. This is the apparent wavelength. Apparent wavelength. Lambda by Vf is actual wavelength. Able to understand? I think there's a very, very good formula. Just you have to take help of this condition. Almost in every numerical. So what is apparent wavelength? The speed with which the velocity of wave with respect to observer by apparent frequency will give the apparent wavelength. Okay, similarly for second case. This is the apparent frequency, no? Then here with what speed the waves are moving, like in air with a speed V, then what is the apparent wavelength will be? Apparent wavelength is equal to V relative by apparent frequency. Then what is the V relative? V minus V naught. Why? Because the waves are moving in the direction of motion of the observer. What is the relative speed? V plus V minus V naught. Is it okay? Relative motion. What is the relative motion between the wave and the observer? V plus V naught. Here V minus V naught by F2. Apparent wavelength. Okay, got this. Then next again, similarly, for next case, we'll take it. These are very fundamental. Almost in every numerical, we are going to take help of this situation. No, no. What about the lambda 3? How, in what action the wave will approach with the speed v like this? So this will be v relative by f3. V relative in this case, v minus v naught. Apparent frequency v minus v naught f by v minus vs. This is apparent frequency. Similarly, for last one, the wave will approach with a speed v nu. So what is the relative motion between the wave and the observer? What is the speed of the wave with respect to observer? So lambda 4 is equal to v relative by f4. Okay, look at, well, it depends on speed of observer. In this situation, may not be. In some of the cases, I can show that even it depends on speed of observer, but you can look at the final answer. VO is not there, no? You see, look at final answer. So do we have anything VO, speed of observer? No, it's not available, no? Got this? So like this, what happened? We can determine the apparent wavelength. Got this one? Okay, now let's take the effect of wind